Hello students, welcome to this session. I've just solved this JEE main test 70 on this NTA ABHYAS app and I'm doing this analysis of the physics part. The paper was a regular one. You have almost 8 questions easy, 4 very tough. This question number 18 uses a term which is I don't know many of you would be remembering. For 2 I suppose the answer given is not appropriate as per the language of the question. So all in all it's a balanced paper, not a tough one, not very easy, but it could be a scoring one. Let's say that's what I always say. For a good student who feels that physics is somewhat better for him, he should get 55 plus 60 plus here, and for a very good student aspiring for advanced 85 or 80 plus must be the score for him in this paper. Let's begin the paper. Energy levels ABC of a certain atom corresponds to increasing volume values of energy. Energy levels ABC of a certain atom corresponds to increasing value of energy. Okay, EC greater than EB greater than A. If lambda 1 lambda 2 be the wavelengths of transition corresponding to C2B, B2A and C2A. Okay, so let me have it like this is EC, this is EB and this is EA. Okay, put it a bit lighter. Yeah, now so lambda 1 corresponds to C2B and B2 is lambda 2 and C2A is lambda 3. So I can directly say that E3 corresponding to lambda 3 would be equals to E1 plus E2, or you can say HC by lambda 3 is HC by lambda 1 plus HC by lambda 2. That is what you can write. So now what you have, you directly get from here 1 by lambda 3 is 1 by lambda 1 plus lambda 2. You can write it as lambda 1 lambda 2 or lambda 1 plus lambda 2. So it's an easy one. Just draw the diagram and you can easily make it out. Next one. An ammeter, voltmeter and resistor are connected in series to a cell and the readings are noted as I and V. If another R is connected in parallel with a voltmeter, then okay. So what we have, they are connected in series to a cell. So let's say this is an ammeter, this is a voltmeter and this is a resistor. They are connected in series. Okay. If the current is I and the voltmeter reading is V, if another resistor R is connected, what will happen in parallel? So what we can make out now, ideally if it is a voltmeter is an ideal one. If the voltmeter is an ideal one, then there would be no effect, but for a real one, it will have some resistance. Now what happens? Originally the resistance was RA plus RV plus R, and now the finally resistance becomes RA plus RV. Because of that, R parallel becomes R by 2. So the final resistance is decreased, therefore the current will increase. So the current is definitely going to increase, that is for sure. Okay, we have option V also. What happens to the voltmeter? Now the value of the voltmeter, will it increase or will it decrease? The value of the voltmeter definitely will also increase. So the V will also increase because its proportion will increase. So I and V both will increase. Though the answer is given as only I increases, I don't know why they have assumed that voltmeter is connected in parallel, but it is not written here. It is written they are connected in series. So I'll go for A, not for B here. Next one. The resonance frequency of LCR series AC circuit is F0. Now the capacitance is made 4 times and the new resonance frequency would be. What do you know that omega naught is 1 by root LC. So if the capacitance is made 4 times, omega becomes half, so frequency also becomes half, so it becomes F0 by 2. There's no doubt about it. It's an easy one for you. So this is F0 by 2. Yes, this is the answer they have also provided. Next. 2 cars start from a point at the same time in a straight line, at their positions are represented by xp is at plus bt square, xqt is ft minus t square. So both are t square, that means both are uniformly accelerated. So when they have the same velocity, so velocity is given by differentiation. So what is the velocity of x? P, that is Vp is a plus 2bt, and that should be equals to f minus 2t. So what do you get? A minus f, or you better write f minus a, that would be equals to 2t common, it becomes 1 plus b. So t comes out as f minus a upon 2 times 1 plus b. So again, not a tough one, it's an easy one considering the JEE main standards. Simply you have to differentiate and simply equate, the value automatically comes. Next. Rocket with a speed v u equals 3 root gr, definitely greater than the escape speed. What would be the speed at the interstellar space? So what you can say, half mu square initial energy, which is 3 means 9 gr, minus gmm by r, that is the initial energy. Final potential is 0, that would be equal to half mv square. So what you can do this, you can write this gmm by r in terms of mg. This is, you can write it as this is mgr because g is gm by r square. So what you have, 9 mgr by 2 minus mgr equals half mv square. So this m goes. So 9 by 2 minus 1, that is 7 by 2 gr is equal to half v square. So v comes out as root 7 gr. So you can go for this option is C1. Next one. A black rectangular surface of area A emits energy E per second at 27 degrees Celsius. The length and breadth are reduced to 1/3. That means area becomes 1/9. And temperature is raised to 3 to 7. So initial it was 300 Kelvin. Now it is 600 Kelvin. So temperature is doubled. So we know H is proportional to A, T की power 4, A is 1 by 9 and T becomes double 2 to the power 4. So it becomes 16 by 9. So we'll go for 16 E by 9. Again, simple application of what you call as a Stephen Boltzmann law. Next. The ratio of speed of sound in nitrogen to that in helium at 300 Kelvin. So we say V of sound is equal to gamma RT by molar mass m0. So V of sound in nitrogen to V of sound in helium. So gamma being of the nitrogen when being is 7 by 5, of the helium being 5 by 3, mass of helium is 4, nitrogen is 28, rest all factor are same. So basically what you turns out, it is 21 by 25 into 4 by 28. So this is 3, this is 4, goes 3 by 25. So root of 3 by 5. So option C is coming. So this is another easy one for you. Next one. Just remember, one is mono, one is dia. Very long straight conducting wire lies along the z-axis, carries 2 ampere. The integral B dot dl is computed along the, it should be circulation I suppose, along a straight line PQ. Okay, not circulation, along a straight line PQ where P has this coordinate 2, 0, 0 to 2, 2, 0. Okay, so the wire is along z-axis, let's say like this, or it's better draw it like this. Let's say wire is carrying current along z-axis coming towards you. This is x-axis and this is y-axis, and you go from 2, 0, 0. This is the point in xy plane to this point. Like say like this. This is P to Q you are going. Now because we have this current coming this way, so what you have, the field at these points, if you check it, the field lines are something like this. Okay, so if you have to calculate for P dot B dot dl is computed along the straight line, has the coordinate, the integral has the magnitude. So what the magnitude this integral will have, that we will need to calculate now. So what we can do now, so for doing that, it should be, it's tough to go for this, but I can go like this. I can go like 2, 2, 2. That radius would be under root of 2 square plus 2 square, that is 2 root 2. So let's say go to this point, let's call it R. This is 2 root 2, 0, 0. Go by this and go by this. So the value will be like this. B dot dl I can go from here also. So here in this path the field is, if you can see, is perpendicular. So the circulation over PR would be 0. So what I can say, this B dot dl I have divided into this B dot dl 1 over P2R and 1 over R2Q. So what we have now, P2R is 0 and R2Q, we can say the field lines are always along this. So directly that is B into pi R. This is what, not IR. I need to calculate what is the angle it subtends now. So for the angle, see this triangle. Let me do this again. Yes. See this triangle, this length is 2, this length is 2, so this angle comes out as 45 degree. So the length would be what we have, r theta, that is pi by 4 into r, and b would be mu naught I upon what we had, mu naught I upon 2 pi r, and r would be r, this capital R here would be 2 root 2, that I already told you of that point r. So mu naught upon 2 pi r into pi by 4 r. So if you do this, this value comes now as, this is r and r goes, this is mu naught I by 8, and I is 2 ampere, so it is mu naught by 4, that is pi into 10 to the power minus 7. So I go for option D. So it's a very good question being asked. Next one. At the instant t equal to 0, there is a force F equal to kT acts on a body mass m resting on a smooth horizontal surface, time when the body leaves the surface. So for leaving the surface, we can say that kT sin alpha should be equals to mg. So that T would be equal to mg upon k sin alpha. So simply this is what we will have, because to lift up, that vertical component of this F should equals mg, so that the normal becomes 0. Lift up means normal should become 0. Next one. Assuming that about 20 MeV of energy is released per fusion reaction, okay, then the mass of the 2H1 consumed per day in a fusion reactor of power 1 megawatt is. So first of all, how many reactions will be needed, I can calculate. So the number of reactions needed would be 1 megawatt, that is 1 into 10 to the power 6 divided by 20 into 1.6 into 10 to the power minus 13 in joules I have done. So this is the number of reaction, and in one reaction you need, what you need, the mass of 2H1 you are needing. You need 1 means approximately 2 AMU. 2 AMU you can say as 2 upon Na grams, and if you do in grams you have to do, so that would be 2 by Na grams. So now what you have, you will calculate now. So this is what will come. This is not going to be a very large quantity, I suppose. So if I do this, consumed per day, okay, so per day means you have to calculate by per day also. This is what I did per second. So per day means in an hour this is 3600 second and this is 24 hours. So now do the calculations. Let me do this. This is 10 to the power 6, this is 10 to the power 2, that is 10 to the power 8, 24 into 2, let's say 48 into 36, I write it. This is 20 into 1.6, I did 32 into 10 to the power minus 13, and is 6 into 10 to the power 23. So what you have, this is 10, this is 8, so it becomes 10 to the power minus 2, and this is 48 into 36 upon 32 into 6. So if I do this, this is 2, this is 3, this is 6, this is 3, so it comes out as 9 into 10 to the power minus 2 grams, or I can write it as 0.09 gram, that is approximately 0.1 gram. You can make it out from the calculation. This is 0.09 gram, so 0.1 gram. Next one, a block is hung from a spring in a cage. Elongation in spring is x1 and x2 when the cage moves up and down respectively with the same acceleration. The expansion when the cage moves horizontally with the same acceleration is okay. Moves up and down respectively with the same acceleration. So when it moves up, the elongation in the spring okay, is hanged from a spring in a cage, moves up and down respectively. So what will be the elongation? So simply you can say x would be, you can say when it goes up, you can write kx minus mg should be equal to ma. So k, let's say x1, that is would be equal to, x1 would be equal to, you can directly write it as m a plus g by k when it goes up, and when it goes down similarly it would be m g minus a by k. You can do there you will write mg minus kx2 equals to ma downwards. So this x2 comes out as mg minus a by k. This is x1 and x2. Now when it goes horizontally, then what you will have, it goes horizontally, then you directly can say kx would be the resultant of that, because that ma and mg are perpendicular to each other, so that would be mg square plus a square for sure. So kx would be m g square plus a square under root. So what I can write now, this is g square plus a square under root. This is not that easy one to simplify. This x is m by k under root g square plus a square. Now I have to eliminate it in terms of x1 and x2. So the best thing would be, let's say, what should we do? If we calculate x1 square, let's say x1 square would be m square by k square into a plus g whole square, and x2 square similarly is m square by k square a minus g whole square. So if I add the two, what I will get, x1 square plus x2 square, what I will get, m square by k square. If I do this would be 2a square plus 2g square. Okay, so that is cancel out. So you using this here, this x square is m square by k square into g square plus a square. So you can directly make out this x square is half of this. So go for option C. That is the answer here. So a nice question. Next one. Two communicating vessels contain mercury. The diameter of one is n times larger than the diameter of the other. The column of water H is poured into the left vessel. The mercury level will rise in the right hand vessel by. Okay. So what we have, water of column H is poured into the left vessel. So how much will it rise? So initially what can I assume? Initially, let's say this was the situation, level of mercury was like this. Now if it rises by, let's say, what we can say, it rises by x, so the volume shifted here would be, let's say, a larger into x, and the volume that will be drifted here would be a times x dash. I can write, let's say, x dash be the drop here. So first of all, what I can say, ax dash would be ax. So what we have, that x dash would be in terms of that a by a, and diameter is n times larger, so it a by a would be n square, so that is n square times x. Okay, now what you have, this h length of water. Now you have, now at the bottommost point the pressure must be same, so what I can write, or at the bottommost point of this only you can check it, so that what we can have now, the level between them rho gh, and that has come over it, so that rho gh, that difference would be made up by the difference of this, that is rho mercury into g, and the difference would be x plus x dash, because it goes x and it dips by x dash, the difference would be x plus x dash, that pressure must be balanced, so that x dash you know is rho mgx, and it would be 1 plus n square. So this is rho gh, rho is of the water I am taking, this is g. So now what you need to have this the x would be rho upon rho of mercury into 1 plus n square, and this you can write as times h, and this is the specific density. If you know, it is given as, so relative density would be s into 1 plus n square. So it goes by, no, not this one, you should not do this mistake, this would be this one, going by the logic. So it's a very nice question. Next, in the figure given below, for an angle of incidence 45 degree at the top surface, what is the minimum refractive index needed for TIR at the vertical face? Okay, so this is 45 degree minimum refractive index needed for TIR. So what we say, if this angle is r, and limiting case this would be equal to theta c. So what I can say, theta c plus r is equal to 90 degrees, so r is 90 degree minus theta c. So what we have, 1 into sine 45 must be equal to n sine of 90 minus theta c. Sine of 90 minus theta c is cos theta c. Now sine theta c would be equal to 1 by n, so cos theta c you can make it out, it would be what you can say n, and it would be n square minus 1. So n goes, sine 45 degree, that is 1 by root 2 is n square minus 1 to the power half, so n square minus 1 is half, so n square comes out as 3 by 2, so n is root 3 by 2 for the limiting case. You could go for this. Next one, weightless rod length L carries two equal masses, one fixed at the other in the middle of the rod. Okay, the rod can revolve in a vertical plane about A. Then horizontal velocity which should be imparted to end C of the rod to deflect it to the horizontal position is, okay, so you have to impart the velocity at the end C so that it can deflect to the horizontal position. So whatever velocity you will impart it, if you impart it v, you will definitely say it will come out as v by 2 for sure. Okay, so now it should become horizontal. So at this point let's assume both speed becomes 0. So here what I can write particularly, the loss in energy would be half m, one is v by 2 square plus half m v square, that should be equal to the gain in potential energy. The first one goes by mgl by 2, the second one goes by mgl. So this m goes, this is v square by 8, this becomes v square by 2, this becomes 3gl by 2. So what we have, v square by, this is 5v square by 4, 2 I have cancelled, that is equal to 3gl. So the velocity comes out to be 12gl by 5 under root. So this is the option. If I have, yes I have, so this is option A. Nice one, this one also. In a CE transistor amplifier, output resistance is 500 kilo ohm, current gain is 49. If the power gain is this, the input resistance is, power gain is AV into beta, beta is 49. So voltage gain, from here you can make it out what it comes, voltage gain is 5 into 10 to the power 6 by 49, and that voltage gain is equal to, again what you know, beta RC by RB. So this output is 500 kilo ohm and this by RB, and this beta is again 49, so that RB or input resistance, whatever you write it, that is 49 into 49 into 500 into 10 to the power 3 upon 5 into 10 to the power 6. So this goes 100, so cancel it up, it becomes 49 into 4.9. So 49 into 4.9, you can make 55s are 250, it would be less than 250, very close to that. You simplify it or you can solve it like do this. 49 9s are what we have, 49 9s are 490, 450, 441. 9 for now 49 4s is 196 and 44, 196 and 44 is 240, so it would be 240.1, so it is 240 ohms that you can directly go for. Next, a calorimeter contains 0.2 kg water at 30, in which 0.1 kg of water at 60 is added. Okay, the mixture is well stirred and the resulting temperature is 35. The thermal capacity of the calorimeter is, okay, So the thermal capacity of the calorimeter, the answer is in joule per Kelvin. That means you do not need to calculate that mass, it is joule per Kelvin only. So what I can say, the Q taken by calorimetry plus Q water in calorimetry would be equal to Q lost by hot water. That is what we can say. So what is the heat lost by the hot water? 60 to 35, that is 25 into 0.1 kg into specific heat, that you write it as let's say SW, write it like this. Now this QC plus QWC would be 0.2 into, it has gained 5 into what I can write as SW, and this would also be S into 5, capital S is I am taking as thermal capacity. So this is 5 into 0.21 SW, that is 25, 2.5 and 2.5 SW I can write. Okay, so what we have, 1.5 SW by 5, that is capital S, that is equal to SW by, I can write it as SW into 0.3 I can write, and 0.3 of SW is 4200 approximately. So 42, this is 420 into 3, that comes out as 1260 joule per Kelvin. So you can go for B. So it's again a nice question. If you are practice this calorimetry one, you can do this. The dimensional formula of electron mobility. So mobility I remember is Vd by E. So velocity is Lt minus 1, electric field is Q by F by Q. F is ml t minus 2, Q is at. So this becomes ml a minus 1 t minus 3. So what you have, m minus 1 L goes, t plus 2 a minus 1. So what we have, m minus 1 L0 t2 a minus no a minus 1. So this one is which one is, I have done some mistake or something. It is by a, so it is a minus 1, so it would be a plus 1, sorry, a was in inverse, so this is d1, I am right. Okay, it was good that option was not like that. So m minus 1 L0 t2 a plus 1 you can do for. Next, the intensity ratio of the two coherent sources of light is P. They interfering in the same region produce an interference pattern. Then the fringe visibility is, now fringe visibility you can remember is Imax minus Imin upon Imax plus Imin. This is the term that frankly not many students are aware. They have asked this. This is not the standard term that generally used or taught. So if you don't know the term, this would be a tough one for you. So it would be Imax minus Imin. So Imax minus Imin or Imax plus Imin. So if you do that, you remember Imax is I1 plus I2 plus 2 root I1 I2, and that is equal to Imin is I1 plus I2 minus 2 root I1 I2, if you remember this thing. So this becomes, this 2 and 2 will become 4 root I1 I2, and this Imax plus I1 will become 2 I1 plus I2. So what you have, this V as 2 root I1 I2 upon I1 plus I2. Now the intensity ratio of the two is P. So one is X, so there would be P times X. So let's say it would be 2 root P times I naught, and one is I naught, one is P times I naught, and this would be P plus 1 I naught. So what we will get now, and this would be I naught square, so that I naught goes, so 2 root P upon P plus 1. So again, if you don't know the term, this would be a tough one. Next, the fundamental frequency of a closed organ pipe of length 20 is equal to the second overtone of an organ pipe open at both end. Okay, the length of the open fundamental of closed is 4 upon L of closed. Second overtone means third one, that is 3V by 2 L of open. So L of open comes out as 6 times LC, that is 120 centimeter. You can directly go for this. Just read it carefully. Don't do any mistake. Otherwise it will cost you. Next, engine of this power pulls a train of this mass with a velocity of this. The coefficient of static friction is. So what is the coefficient of static friction? We can say the power would be equal to Fk into V, because that would be negative, that is positive being delivered. So this is 58.8. You have kilo 10 to the power 3. Fk would be this mu times mu k times mg. Mg is 2 into 10 to the power 6. 36 is 10 meter per second. Just remember, convert into 10. So mu k comes out as 58.8 into 10 to the power 3 divided by 2 into 10 to the power 7. So it becomes 10 to the power minus 4 into this becomes whatever I can write, it is 29.4. So it is 29.4 into 10 to the power minus 4, that is 0.00294. So that is 0.003. You will go for option C in this particular case. So it is a very, very small coefficient. Then also that much power is required because the mass is too large. Now the numerical ones, a 5,000 kg rocket set for vertical firing, exhaust speed is this, to give an initial upward acceleration, the amount of gas ejected per second is. So what we can say that thrust force should be equal to mg plus a. Thrust force would be, let's say, dm by dt, amount of gas ejected per second into relative speed, which is 800. Mass is 5 into 10 to the power 3. G plus a would be 20, that is 30. So now what we have, dm by dt comes out as, this 5 3s are 15 into 10 to the power 4 upon 800. So that is 1500 by 8. And 1500 by 8, if you do this frankly, what you will get, 8. This is 1, this is 70. 70 means 8. Then 60. 60 means 7. So that is 187.5 to be precise. Next one. A particle describes a horizontal circle in a conical funnel whose inner surface is smooth with a speed this. At what height of the plane of the circle from the vertex of the funnel? Okay, so it's a conical funnel like this. You have this like, okay. So it would be executing like said somewhere here. So because it is smooth, what I can say, this would be normal, this would be mg. Okay, so now what I can make it out, this is the radius. And let's say this is h. So first of all, let me do this angle to be theta. What I can write, n cos theta is mg and n sin theta is equal to mv square by r. That is what we can make it out. Okay, so from here what we get, tan theta is equal to, what I can write, v square by rg. That should be followed here, and this angle is theta, and I've taken that to be theta. Okay, I've taken that to be theta, that is theta. So now if this angle is theta, this will also be theta. So what I can have, tan theta I can also write as h by r. So what is the height? So height you can make it out, and what we can have, tan theta is h by r, and what is r? R is going to be, what we can say, tan theta is h by r, and the radius is similarly in terms of height I have to calculate. So if I do, okay, r and r get cancelled, so I get this formula, the thing is solved. So h is v square by g. So v square is 1 by 4 and g is 10. That comes out as 1 by 40 meters or 2.5 centimeters. So it's a good one. I was searching how to write this r, but that r was getting cancelled easily. So nice one, 2.5. Next. A 10 microfarad capacitor is charged to a potential of 50 and connected to another uncharged in parallel. Now the common potential is 20. What is the value? You directly know V common is C1 V1 plus C2 V2 upon C1 plus C2. Here V2 was 0. So 10 into 50, I'm taking units to be same. That is 50 plus C2, that is 20. So what do you get? What you will get, this is 25. So what we will have, 50 plus C2 is going to be not 50. That's why I was saying there's some issue. This is 10, because that would C would have been negative, so it was my mistake. So 10 plus C2 is 25, so C2 comes out as 15. So 15 microfarad, that you can directly say. Next one. Particle projected from the Earth's surface with a velocity of 50 meter per second at angle theta with the horizontal up to 2 seconds just clears a wall of 5 meter high. What is the value of 55 sine of theta? Okay. So it just clears a wall of height 5 meter after 2 seconds. That means h is equal to 5 would be equal to uy t minus half gt square at t equal to 2 seconds. So 5 is uy is 50 sine theta, t is 2 minus this is 5 into 2 square. So you get that value. So what we will have now, 5 is 100 sine theta minus 20. So 25 by 100 is equal to sine theta. So sine theta comes out as, for you, comes out as 1 by 4. So sine theta is 1 by 4. Now what you need? You require 55 sine theta. So do 55 sine theta. This is 55 by 4, which is 1. This is 15, 13.75 I can go for. So this is the value, 13.75. Next one. Last one. Proton, when accelerated through a potential of this, the wavelength is lambda. An alpha particle to have same lambda, what should be the wavelength? So lambda you know is h by p, h by mv, h by root 2 mqv. So for same this thing, what you need this mqv thing to be same. So proton, it was mp, q is e into v. That would be equal to, its mass is, what do you have? Alpha is 4 mp, charge is 2e into v dash. So v dash would be v by 8. 29.6 by 8, this comes out as 324. What you are left with, 56, that is 3.7. So the answer is 3.7 volts, and this completes our paper. Thanks for watching. Keep liking, keep sharing, keep commenting on the channel. Thank you once.